Our member is Evi Wulandari, Erliysha Saputri, Nur Fauziah, Affani Laila, Anisya Putri, Desi Liana, Hilmiyatul Mubarok, and the last one is Hana Katolin Ulan.
Okay, the first presenter is Hana Ulan, who will discuss non-parametric definition.
Hello, my name is Hana Ulan from Group 4. So, I will explain about the definition of non-parametric. So, non-parametric statistic is a method that makes statistical inference without regard to any underlying distribution. The method fits a normal distribution under no assumption. Habitually, the approach uses data that is often ordinal because it relies on ranking rather than on number. Non-parametric statistic can be contrasted with parametric statistic. The latter approach makes explicit assumption about the distribution of observed data and estimate the parameters of the distribution using same data. Understanding non-parametric statistic. Consider the data with unknown parameters, mean and variance, while parametric statistic assumption that the data were drawn from a normal distribution. A non-parametric statistic does not assume that the data is normally distribution or quantitative. In that regard, non-parametric statistic would estimate the shape of the distribution itself instead of estimating the individual mean and variance. In the other hand, parametric statistic would employ sample mean and sample standard deviation to estimate the value of mean and variance respectively. The model structure of non-parametric statistic is deduced from the observed data as opposed to a specific priori. The term non-parametric itself implies that the number and nature of parameters are flexible and not that they entirely lack parameters.
We have here the definition of non-parametric. Then there is the basic principle of non-parametric, will be explained by Evi Wulandari.
Hi there, my name is Evi Wulandari. Before going to explain about non-parametric, I would like to introduce the basic principle of non-parametric, or why and when we use non-parametric. In short, previously meeting, we have known the types of statistics based on data distribution are parametric and non-parametric. In particular, there are two most basic prerequisites for parametric statistical analysis. The first, the assumption of normality, which specifies that the means of the sample group are normally distributed, and second, the assumption of equal variance, which specifies that the variance of the samples and of their corresponding population are equal. Hence, parametric statistical analysis are conducted on the premise that the above assumptions are satisfied. And I will explain the non-parametric. This is the slide. Okay, the basic principle of non-parametric. If we have a skew like this, positively or negatively skew distribution, then we ought to calculate use non-parametric we use. Parametric statistical technique cannot be used. Why? Because non-parametric statistical analysis greatly for this calculate different from parametric statistical analysis in that it only use plus or minus sign or the rank of data size instead of the original values of data. We can calculate use non-parametric. In other words, the non-parametric analysis focus on the order of the data size rather than on the value of the data per se. Well, parametric analysis focus on the difference in the means of the group to be compared, whereas the non-parametric analysis focus on the rank. There be putting more emphasis on difference of the median values than the mean.
The third material is a method of non-parametric. Non-parametric have two methods. The first method is Wilcoxon rank sum statistic, will be explained by Nur Fauziah.
Assalamualaikum warahmatullahi wabarakatuh. Hi guys. So let me introduce myself. My name is Nur Fauziah. Today I will explain you about methods. So in the non-parametric statistic, have two methods. What that? The first is the Wilcoxon rank sum statistic. And the second is the Wilcoxon sign rank statistic. And no, I will only explain you about the Wilcoxon rank sum statistic. Okay. What is the Wilcoxon rank sum statistic? The Wilcoxon rank sum statistic is appropriate for analyzing data from two groups of different people. Okay. The Wilcoxon rank sum statistic is appropriate for analysis of the data because the independent variable in the study type of feedback is nominal and has two levels, and the dependent variable, level of motivation, yields rankable scores. Okay, and then the Wilcoxon rank sum statistic is a non-parametric statistic. The model for determining statistical significance is not the normal distribution. So, the Wilcoxon rank sum statistic is a model for determining statistical significance is not the normal distribution. Okay? And that when the two sets of data are combined and ranked, the Wilcoxon rank sum statistic allows a researcher to determine whether the rankings are randomly distributed or distributed in such a way that one group tends to rank differently than the other. Okay, my friends Evi Wulandari already mentioned that the Wilcoxon rank sum test can be used to test the null hypothesis that two populations have the same continuous distribution. Okay, and move to the what is the Wilcoxon rank sum statistic. Now I will show you what the steps the Wilcoxon rank sum statistic. In the Wilcoxon rank sum statistic have 10 steps. The first step is state the formal research hypothesis, the null hypothesis, and the alternative hypothesis. a few weeks ago, Miss Maria explained what is the null hypothesis and the alternative hypothesis. Okay, the second is set alpha. Set alpha. Jadi, so the level of probability for interpreting the analysis. So what is the set alpha? The set alpha is the level of probability for interpreting the analysis. And the third is select the appropriate statistic for analysis of the data. Okay, and the fourth is collect the data. And the fifth is verify that the condition for appropriate use of the statistic, the assumption are met. Okay, I will show you 5 steps in these 5 steps. The first step is state the formal research hypothesis. The second is set alpha. The third is select the appropriate statistic. The fourth is collect the data. And the fifth is verify that the condition for appropriate use of the statistic. And then 6 steps. Step 6. Calculate the observed value of the appropriate statistic. In step 6, you must calculate the observed value of the appropriate statistic. Okay. The 7 is calculate the exact probability for the observed statistic calculate in step 6. So after you calculate the observed value of the appropriate, you calculate calculate the exact probability for the observed statistic calculate in step 6. Okay. And the next is compare the exact probability to alpha. If exact probability greater than or equal to alpha, accept the null hypothesis. If exact probability is greater than or equal to alpha, accept the null hypothesis. But if exact probability is less than alpha, reject the null hypothesis. Okay, if exact probability is greater than or equal to alpha, accept the null hypothesis. If exact probability is less than alpha, reject the null hypothesis. You must reject the null hypothesis if exact probability is less than alpha. Okay. The next is interpret the outcome of the analysis as a probability statement using the hypothesis accepted in steps 8. Okay. And the last is interpret the meaningfulness of the findings and calculate the effect size if possible. Okay. So from the 10 steps, the first step is state the formal research hypothesis. The second is set alpha. The third is select the appropriate statistic. The fourth is collect the data. The fifth is verify that the condition for appropriate use of the statistic. And the sixth is calculate the observed value of the appropriate statistic. The seventh is calculate the exact probability for the observed statistic calculate in step 6. And then compare the exact probability to alpha, and then interpret the outcome of the analysis as a probability statement using the hypothesis accepted in steps age, and the last is interpret the meaningfulness of the finding and calculate the effects if possible. And my friends Hilmiyatul Mubarok will show you the example of the Wilcoxon ransom test. Okay, that's all from me. Assalamualaikum warahmatullahi wabarakatuh.
And the second method is the Wilcoxon sign rank statistic, will be explained by Anisya Putri.
Hello, I am Anisya and I will present the next material. If in the previous explanation we have seen and heard an explanation one of the Wilcoxon test methods, that is Wilcoxon sum rank test. Now, I will explanation about the second methods of Wilcoxon test. In the non-parametric, we can use the Wilcoxon test to analyze and test our data. The Wilcoxon test is divided into two methods. The first one is the Wilcoxon sum rank test or statistic, and the second one is the Wilcoxon sign rank test. If the Wilcoxon sum rank statistic is appropriated for analysis data from two groups of different people. So, how about the second methods of this Wilcoxon test? That namely the Wilcoxon sign rank test. In the slide, we can see the Wilcoxon sign rank statistic definition. The Wilcoxon sign rank test is the non-parametric test equivalent to the dependency test. As the Wilcoxon sign rank test doesn't assume normality in the data, it can be used when this assumption has been violated and the use of the dependency test is inappropriate. The Wilcoxon sign rank test can be used to compare two sets of scores that come from the same participant. This can occur when we wish to investigate any change in score from one time point to another, or when individuals are subjected to more than vision. So, the Wilcoxon sign rank test is a non-parametric test to measure the significance of the difference between two groups of pair data with an ordinal and interval scale, but with an abnormal distribution. The Wilcoxon sign test is an alternative test of the t-test if the population data doesn't follow a normal distribution. The Wilcoxon sign rank test is equivalent to dependency testing. What is the dependency test? Dependency test is a type of statistical test that aims to compare the pair means of two groups. So, what is the function of the Wilcoxon sign rank test? So, we can use the Wilcoxon sign rank test to compare two relate sample, match sample, or repeated measurement. One a single sample to assess whether their population mean rank differ. So, differences between the Wilcoxon sum rank test and Wilcoxon sign rank are in the sample or data. If the Wilcoxon sum rank test two independent sample, and then the Wilcoxon sum rank all one sample or mixed prior. So that's all my explanation. Thank you.
Okay, that was the explanation of the two methods of non-parametric. The next material is an example when will be explained by Hilmiyatul Mubarok and Affani Laila.
Hello everyone, my name is Hilmiyatul Mubarok. So I will deliver the example of Wilcoxon rank sum test. The Wilcoxon rank sum test is give two independent samples. The test statistic Z for the Wilcoxon rank sum test is Z equal R minus mu R divided by sigma R. So R is rank, mu R is median rank, and sigma R is standard deviation rank, where R is sum of the ranks for the smaller sample. And then this R is the formula for mu R and standard deviation R. The formula of mu R equal n1 times n1 plus n2 plus 1 over 2, and standard deviation R equal square root n1 times n2 times n1 plus n2 plus 1 divided by 12. So this is the example of Wilcoxon rank sum test. The table shows the earnings in thousands of dollars of a random sample of 10 male and 12 female pharmaceutical sales representatives at alpha is 0.10. So can you conclude that there is a difference between the males and females earnings? So we have the data. The total data for female is 10, and the total data for female is 12. And then, as we know from the explanation before, there are 10 steps to solving the Wilcoxon rank sum test. So the step 1 is that hypothesis null and hypothesis alternative. So the hypothesis null is there is no difference between the males and the females earnings, and hypothesis alternative is there is a difference between males and the females earnings. And then the next step is the alpha is 0.10. And alpha is given to us to be 0.10. Since there is no difference, it should be a two-tailed test. So we were able to find with our alpha values, we were able to find our Z. Remember our Z here, we have to use 1 over 1 minus alpha over 2. So when you are looking for critical value and you are using Z tables, all you need is only the alpha because it will be Z1 minus alpha over 2. So you plug in the alpha 1 minus 0.1. Over the Z table and look for it, and here since we are going to test, we divide the alpha into 2 like that, 0.05 to the left and 0.05 to the right. So we have negative and positive. Center will be our 0. So to find the critical value, we need to find the values of R, mu R, and standard deviation R. Construct a table that shows the combined data in ascending order and the corresponding range. So this is the ranks of the data. Before we ranking them, we combine the both of data. An ascending order means from the lowest to the highest. So we look our data, you can see that male and female are is missed because we are looking the lowest value in the data was 57, and that start with the female. We rank it as 1, and the next value is 58. That was a male. We rank as number 2. We combining the whole data, here male and female together. The lowest value is female, 57, and the next is 58, and we keep going. So that's we do combine both female and male, and we rank everything. Sometimes we may have 5.5 like that. It means we have the same value twice. We have the two same data. When there are two same data like that, to rank them, we calculate the ranks if there are two same data like that. Example, rank of the data is 10, but there are two same data. We calculate like that. 10 plus 11 equal 21. So 10 plus 11 equal 21, and then 21 divided by 2 equal 10.5. So like that. And then the next is we find sum of ranks of data. So sum of ranks for male is 115, and sum of ranks for female is 138. So because the smaller sample is the sample of males, R is the sum of the male rankings. Using N1 is 10 and N2 is 12, we can find mu R and standard deviation R. Mu R equal N1 times N1 plus N2 plus 1 divided by 2. So like that, 10 times 10 plus 12 plus 1 divided by 2 equal 115, and then the standard deviation R equal square root of N1 times N2 times N1 plus N2 plus 1 divided by 12. So like that, square root of 10 times 12 times 10 plus 12 plus 1 divided by 12 equal 15.17. So now we calculate or find the C. So the formula for C is R minus mu R divided by standard deviation R equal 138 minus 115 divided by 15.17. So the result is 1.52. So now we will look at the rejection region. 1.52 fall in the brown section, which means except so we say our decision is failed to reject hypothesis null. The rejection ratio will be the blue area. That's the rejection for hypothesis null. So here we say at the 10% level of significance, you cannot conclude that there is a difference between the males and females earnings. So that's it. I think that's all from me. Thank you.
Here I will explain about the Wilcoxon Signet rank test, and this is for the other example. So the first is you could use a Wilcoxon Signet rank test to understand whether there was a differences in smokers' daily cigarette consumption before and after a 6-week hypotherapy program. And then you could also use a Wilcoxon Signet rank test to understand whether there was a differences in reaction times under two different lighting conditions. And for next, so this is the example with using SPSS. So this is the example of the data, and then from the data it can be concluded that you have a data set consisting of 15 research subject or sample. Each subject has two data, namely pre-test and post-test data. And this research objective was to prove whether the differences between pre-test and post-test scores was statistically significant. Because the test we are going to do must adjust to the research objective and the hypothesis met, then face a case like the one above, where the form of the hypothesis is the differences between the two groups of paired data. The main choice is the parametric test, namely the parity test. To ascertain whether the existing data meets the parity test assumption, namely the assumption of normality on pair differences, it is necessary to first test for normality on the differences. And next, the trick is on the menu, click transform, compute, and then compute variable. Click the compute variable option, and then after the window opens, name the difference variable with the name diff without the quotes. Then in the numeric expression box,
type the formula pretest posttest. This formula means that the pretest value is reduced by the posttest value. And then after you press the OK button right here, look at the data view in your dataset. It appears that a new variable named div appears. Next, do the normality test on the div variable using the Shapiro-Wilk test. And next, on the menu, click Analyze, and then click Non-Parametric Test, and then click to Relate Sample. After the window opens, enter pretest into the variable 1 box and posttest into the variable 2 box by pointing the selection to pretest or posttest. Then click the arrow to the right. Then check Wilcoxon and then press OK. And then next, click the option button and check the descriptive. Click here and then check descriptive. Okay, next, look at the output. The descriptive statistic table above show the mean, standard deviation, minimum and maximum value of each group, of each data group, pretest and posttest. It appears that the mean of average posttest value is 60.6667, which is greater than the pretest value, namely 53.6667. And then next, based on the calculation method used in the Wilcoxon Segner rank test formula, the value obtained are the mean rank and the sum of rank of the negative rank, positive rank, and the t's. So negative rank means that the sample with the value of the second group or posttest is lower than the value of the first group or pretest, and then positive rank are sample with the value of the second group or posttest higher than the value of the first group or pretest, and then while the ties are the value of the second group or posttest which is equal to the value of the first group pretest, and the n symbol indicates the number. The mean rank is the average rating and the sum of rank is the sum of rating.
Earlier we have explained the definition, basic principle, method, and the example of non-parametric. Okay, non-parametric also has advantages and disadvantages, and this material will be explained by Erliysha Saputri.
So, I will explain about advantages of non-parametric statistics. First, there is less of possibility to reach incorrect conclusions because assumptions about the population are unnecessary. In other words, this is conservative method. Second, it is more intuitive and does not require much statistical knowledge. Third, statistics are compact based on strings or flanks and thus are not greatly affected by outliers. 4. This method can be used even for small samples. 5. Non-parametric test sets with median could be better for several study areas. And the last one is non-parametric test can analyze ordinal data, ranking data, and outliers. And disadvantages. First, actual difference in a population cannot be known because the distribution function cannot be stated. Second, the information acquired from non-parametric method is limited compared to that from parametric method, and it is more difficult to interpret it. Third, compared to parametric method, they are only a few analytical methods. Fourth, computation becomes complicated for a large number. Fifth, the non-parametric statistical test is that the test is not systematic. And the last one, the tables required to implement non-parametric testing are widespread and appear in different formats.
Finally, there is a conclusion for all of our material that will present by Arfia Nanda.
Okay, so I'd like to explain for the conclusion of non-parametric in the statistic. So the non-parametric tests are attractive because they do not require an assumption of the normal distribution. Even when the data do come from normal distribution, these non-parametric tests do not sacrifice much power in comparison to tests based on the normality assumption. Although these tests were designed to be used with continuous data, they are often used with ordered data as well. Maybe that's all from us. Thank you.
Okay, that was all the material that we have present about non-parametric. Hopefully what we convey will be received well. Thank you and stay healthy.